Plan for this week, so we will probably have I'll have specific dates for you tomorrow. Probably that final, the last week of May, Wednesday, Thursday, I'm giving the final. We're not on a final schedule, so you'll take the 1 hour. You'll have 1 hour Wednesday and 1 hour Thursday, and I'll split the final up. So probably that Monday, maybe we'll have that unit circle quiz, and the Friday before, maybe we'll have we'll have a homework quiz. So maybe that Monday we'll have actually we won't be here Monday. That Tuesday I may do the unit circle quiz before the Wednesday, Thursday final, and then that week before maybe we'll do the theorem quiz. But I'll give you specific dates. And I'll give you a list of specific theorems. My goal is to do that tomorrow. A list of theorems you have to have somewhat memorized. Okay, so let's look at 9. Critical numbers of the following differentiable function. Critical numbers we've talked about before. How do I find critical numbers?
You gotta set the first derivative.
Fluxion points are second derivative set equal to 0. Critical numbers are where the first derivative is set equal to 0 or where the second derivative is undefined. I have polynomials, so I'm probably not going to have to worry about where they're undefined. So I'm going to take the derivative. Now, just because it's a piecewise, don't stress out. You do it the same sort of way. So this will be 3x squared minus 1. When x is less than 0, I'm just taking the derivative like normal. And this would be x squared minus 1 when x is greater than or equal to 0. So just because it's a piecewise, you do the same sort of thing. And you're just going to, I got stuck on this a little bit because I was thinking about when I set it equal to 0, I was thinking about x is 0. So that's why I was like, well, you're only going to get 1 as an answer. But we're not setting x to be 0, we're setting y to be 0. So you really technically are going to set both parts equal to 0. So not terrible once you kind of get past it looking weird because of the piecewise. So take the piecewise, we're going to set, to find the critical numbers, is where the first derivative is undefined, so set them both to, it's where the first derivative is undefined, which we're not going to have because we have polynomials. It's also where the first derivative is equal to 0. So we set each part equal to 0, add 1, so 1/3 equals x squared, divided by 3, square root, so 1 over square root of 3. You take the square root of the top and bottom. Do what?
Plus or minus, right?
Could be minus. It cannot be minus because no, it has to be minus because yes. So that's a good catch. So it's technically plus or minus, but for the top one, it's only for x values less than 0. So it's only your negative. 1 over square root of 3. And then this would be add 1, so 1 equals x squared. Again, you have to kind of use that piecewise, so technically it would be plus or minus 1 when you take the square root. But this is only for x values greater than or equal to 0, so that's just a positive 1. So your answer is D. So let's keep track of that plus or minus. That's where that piecewise comes into. Okay, let's look at 10. Yes.
Okay. So I know that it's going to that, but since it'll never reach 0, it can't be 0, right? Because it'll always be 1. Because there's a 1 on bottom. Right? But I remember there was one like that where the answer was 0. I just don't remember if it was this one.
You have a constant, and your bottom's getting bigger and bigger. So what's always... If I have a constant over a denominator that's getting bigger, 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 the whole fraction is going to.
Smaller.
Yes.
So it is.
But will it ever turn negative? Will I ever get negative numbers from that? By plugging in bigger x values?
So it's just negative? Or just infinity?
It's getting smaller, but it's approaching
0.
Yes. Okay, let's look at 10. 10 is a nice one. I would be happy if one like that showed up. So all I'm doing is it's a definite integral because I have specific endpoints. So I'm just going to integrate. Integral of sine x negative cosine x from 0 to pi. No u sub, no whatever. Just a straight whatever. And then you just plug in pi and 0. So negative cosine of pi minus negative cosine of 0. Cosine of pi, you should have memorized. 0. So negative 0. Cosine of 0. 0? No.
1.
Well, then cosine of pi is
1.
negative 1. Yeah.
Or yeah, negative.
So cosine of pi is negative 1. So negative negative 1. Minus cosine of 0 is 1. So minus negative 1. So 1 plus 1, 2. So check your negatives on. Not bad, but you need this packet.
Did you do the other one?
Yes, I can send you that video. Remind me.
Okay.
Send
You
me
got
an
through the
email.
whole packet?
Did
I
you?
guess I missed 2 days, yeah.
We finished the first one and then started this one.
Okay.
I skipped around a few places, but
Wait, what about this?
we finished it. I only did 13. Here's actually 13 if you...
So 9, 10, 11, 12.
we should have done them. I'll look once we get done with this. Where you weren't here Thursday.
Thursday or Friday.
Thursday we finished it. We did a good chunk Thursday, finished it Friday, and then started that one. Email me and I can send you those videos. Yep. Okay, 11. We are evaluating. Now this it's a definite integral. Now your interval is kind of weird, and it's e and e to the third. Remember, those are just numbers. So even though they look weird, they're just represent numbers. First thought on this? Yeah, that would definitely be my first thought, because I see composite function. Starting spot, let u be what? ln of x, yeah. Let's do the inside part. Inside part or denominator is a good place to start. The denominator, if you let u be the denominator, du, you'd have product rule and quotient rule. It'd get messy. So I'm just going to let u be ln of x. And the more you do of these, the more you kind of derivative of ln of x, 1 over x dx. And you may already kind of notice that that will kind of work out nicely in the denominator because I have that random x out front. So we did do u sub, so I am going to switch my interval and get it in terms of u. So I'm going to take e and plug it in here. Don't overthink this. ln of e is 1, they cancel out. ln of e cubed, 3. So any questions on that plugging in part? So let's plug in what we have. We have u is ln of x, so it's going to be u cubed in the bottom. What is left? 1 over x dx. 1 over x dx. We're good. 1 over x dx is just what?
1.
No? 1 over x dx is du. So it plugs in nicely. It looks complicated, but if you let u be ln of x, the derivative gives you that x in the denominator, and then it works out like this. Yeah. And then to integrate this, I'm going to want to do what first? Bring it up.
Oh, yeah, that's right.
Yes, yep. And then integrating u to the third. Do what to your exponent first? Yep, so negative 2 plus, or negative 3 plus 1, negative 2. What will go out front? Negative a half. And that's from 1 to 3. Now, if you kept your interval in terms of e and e to the third, then you'd have to plug x back in. But since I replaced it at the beginning, we're good. And I can just go ahead and negative a half times 1 over u squared, because I'm just making that u to the negative second to the denominator, minus negative 1/2 times 1 over u squared. I don't know why I wrote it all out. God, that was kind of weird. You're plugging in 3 and 1. I should have just plugged 3 and 1. I'm just going to do it here. So 3, 1. So it will give me 3 squared 9, so negative 1 over 18 plus 1/2. Yeah? Is that right? Any stupid mistakes? So 1/2 over 18 is 9/2, or 9/18. So negative 1 over 18 plus 9 over 18 is 8/18. That is not. Maybe reduce. 4/9. Which is right. Yes.
18 plus 4. Is that what you did?
Do what? Where at? I made 1/2 9 over 18. So negative 1 over 18 plus 9 over 18 is 8 over 18, and then divide by 2. It's only you 3 going on that, right?
Yeah.
I'm still not sure.
Okay. So if you don't go, you'll just take it like final, but if you do, we have a plan.
Yeah, we'll just do the.
That's fine. Yeah. Okay, any questions on that one? Yeah.
The E will cancel out, and then the left will.
He's fine. He's talking to himself, I think.
Okay.
Or I'm ignoring him if he's talking to me, so whatever.
Do I have to add the 0 into this?
Yes. No, because your domain is all real, so you're good.
Okay.
Yeah.
Then it'll just be the-
Yeah. Okay. Are you good, Jackson?
Negative 1/18 minus.
Yes. Yes.
Are you
4.
He's talking to himself, I think. Okay, 12. Linearization, linear approximation, same thing. Okay, so we did a couple like this. I want to do another one with you. Sometimes they give you A, sometimes they give you a number. This case, unlike the one we did last week, they don't give you what number to use. So here's the formula, definitely something you're going to want to know pretty well, because without the formula you really don't have a starting point. So that's why those formulas are important to know, because otherwise there's no hope. I mean, that sounds over dramatic, but so there's a linearization formula. They don't give you an A value here. Since we're taking the square root, we're going to pick numbers that are perfect squares. So we're going to let A to be 4 in this one. So if they don't give you a value to use, like the last value, the last example we did last week, it was 100. So you're going to want to pick, if it's square roots, you're going to want to pick perfect squares. And what function? They don't give me a function, but what do you think my function will be? F of x equals... Sometimes they give you a function, they don't on this one. So you think your function would be square root of x. Yep. And I'm going to go ahead and find f prime of x, so I can use it in the formula. So f prime would be 1/2. Yeah, you're good. Come on in.
Can I borrow a pen for a second?
Yes. 1/2 x to the negative 1/2 when you take the derivative. And then let's start plugging in. F of a would be a plugged into your function, so it becomes square root of 4, plus f prime of a plugged into your derivative, which is 1 over 2 square root of 4. I just put the x to the negative 1/2 as a square root in the denominator. And then x minus a, x minus 4. So sometimes they give you a, sometimes they give you a function, sometimes they don't. You're just going to have to, we've looked at some examples. Most of the ones we did in the notes in the study guide, they gave you f and a. A couple examples we just looked at, didn't it? Any questions on setup? Look at your answer. What answer, just a side note, what answer could I cross off?
A.
You know it's not A, so use the multiple choice to your advantage. We know square root of 3.8 is not 2, so we know it's not A. So let's go ahead and simplify this. Square root of 4 is 2. This will be square root of 4 is 2, so that will be 1/4 times x minus 4. Okay, so we did A was 4, so f of A is square root of 4. We did f prime of A was 4 plugged into the derivative. I just put square root of 4 on the bottom. And then x minus A is just x minus 4. So let's go ahead and distribute the fourth. Let's simplify this. We get an equation first, and then we'll use that equation to actually approximate what they want me to. So 1/4 x minus 1. So 1 plus 1/4 x is my equation. And I'm going to use that equation to approximate the square root of 3.8.
Okay, so
Yes.
to find the A, do you just like you just round the nearest whole value?
Oh, perfect square. Because you're gonna end up having to find f of A, so you want to pick a perfect square.
Oh,
Yes.
okay. That makes sense.
So then I want to approximate square root of 3.8. So you're going to use the formula, and what are you going to plug in for x? 3.8. Because some of the formula was like square root of x plus 2. So then if I wanted to square root of 3.8, x would be 1.8. But this is just square root of x. So x is just 3.8. 3.8 divided by 4. Some good old log division. What's the word I was looking for? Not crap. Okay. You're fine.
Is there an equation missing here, or is it in this? I'm just not getting it.
It's Rolle's theorem. So if you want to look at Rolle's theorem real quick,
Okay.
and then finish it, I'll let you do that. So 3.8, we're going to move decimal over once, bring it up, long division with decimals. This becomes a 40 because I moved the decimal over to the right. So this becomes a 0. 40 goes into 380 how many times? 9, which would be 360. Subtract, that will give you 20. 40 goes into 20 how many times? 0. 0 times 40 is 0. That's 20. Bring down the 0. 40 goes into 200 5 times. There's something wrong. Do I not?
You put a decimal.
Oh, I dropped the 0 and then I don't put that. Sorry. So that would be a 5. It's been a while. So you end up with 0.95 and then plus the 1. So 1 plus 0.95. So 1.95. So it should be E. Yeah, so far this one is.
Well, there was that one, but
I think this is the same person who wrote the final this year.
well, it's the same person.
Well, it's hard to tell, but I don't know. I don't see some of them that have names on the top who wrote them. But I know.
Let me see.
I understand that.
Okay.
A lot more simple than I thought.
Yeah, you're good. Okay. Next one. These ones I don't even want to read because they're long. That's how I would feel, but I'm sure you feel the same way. Okay. Okay. Suppose that f is a function with domain 0 to infinity that is differentiable in its whole domain. If f of 2 is 6 and f of 4 is 8, what does the mean value theorem say? So again, mean value theorem. It's one that I will put on the. I'm thinking there'll be like 4 or 5 that I'll pick out that are like the main ones from calculus. I really think that's all we kind of covered. Where you'll have to take a quiz on. But mean value theorem we've seen pop up before. It is in section. I had it written down somewhere. Agree? I think I wrote it down earlier.
Chapter 3. I think you did write it down.
Right here. 3. It's in section 3, 2. So mean value theorem is section 3, 2. I would put that on. Definitely put that as one of the theorems to put on your memorization list. Okay, let's read it and see. Here's the mean value theorem. Okay, f is a function. Let's see. F is a function with domain 0 and infinity that is differentiable in its whole domain. F is continuous on the closed interval 0 to infinity. I think that's what it means. And differentiable on the open interval. So right here, here's the open interval. It is differentiable on AB, which in this case is 0 to infinity. Then there exists a number C in AB such that f prime of C equals f of B minus f of A over B minus A. That's the formula we want. So that's the key part for mean value theorem. So f prime of C equals f of B minus f of A over B minus A. So let's see what we have. F prime of C equals f of B is what?
8.
8, yes. So we know B is f of 4 because B is always, if you think about an interval, it went A comma B, so B is always the bigger number. So B is 4, so f of 4 is 8, minus f of A, which is the lower number, 2, which is 6, over your B value would be 4, part on the inside. A value is 2. So 2 over 2, that's 1. So your answer is?
R1 equals 1.
Oh, look at them being tricky.
C?
B or C? So let's see.
It says at least one, right?
If f is continuous on a closed interval AB and differential on the open interval AB, then there exists a number C in AB such that f prime of C.
Is it exactly one?
So it's just 1.
Well, it's B or C. The answer is C, they put. Yes. That just must be part of the, yeah, some and not all.
Is this where they equal together, or is it has to get to 0? Because in the notes it goes to 0.
Well, it depends if I'm looking for a 0. Yeah, f of C equals 0, so that's fine. That's fine, yeah.
It is fine.
That looks fine to me for right now, yeah.
Then I'm
Okay, just throw it on the top and all. Thank you. Okay, 14. So again, that one is another example. If you had no idea what mean value theorem is, then that would be hard. I mean, so if you know mean value theorem pretty well, you should be able to take an educated guess. 14. Suppose that f of x is a function that is continuous at the point x equals 1. Which of the following statements must be true? The function is differentiable at x equals 1. The function f of x is continuous for all real numbers. There exists a positive real number delta such that x minus 1, the absolute value of x minus 1, I'm not going to read that, you can look at it. I'm tired of talking. So we have,
I don't remember the sigma thing. You're not sigma with
I think this is delta epsilon.
the delta.
We missed that one. Maybe that one guy. Maybe that guy can be a guest lecturer and come back and teach.
Yeah, that. How did he know?
I don't know. Hey. Yeah.
Stuff like that.
I could take about. That's about all I could take out. We'll come back to that one. I'm not super worried about that. Okay, 15. Suppose that the function v of t, I'll have to go look and see. I'm not going to waste your time looking where that's at, but we'll look at delta epsilon. Suppose that the function v of t represents the upward vertical velocity of a hot air balloon in meters per second, where t is measured in seconds. If the interval from 0 to t of the velocity is 10, and the interval from 2 to 4 of the velocity is -7, which of the following statements must be true about the balloon? At time t equals 0, the balloon is on the ground. At time t equals 1, the balloon is gaining altitude. Time t equals 2, the balloon is 10 meters off the ground. T equals 3, the balloon is losing altitude. T equals 4, the balloon is 3 meters higher off the ground than it was at time equals 0. So, key thing to remember with this one is when I integrate, remember PVA. So when I integrate the velocity, that's actually telling me the position. So what it's telling me, the integral from 0 to 2 of v of t dt, is that the position over that interval is 10. Okay? And then from the position from 2 to 4 is -7. So we're thinking, at time t equals 0, the balloon is on the ground.
No.
So what this is saying is that the change in position from 0 to 2 is 10. Do I know it has to start on the ground?
No.
No, it could have started at 10 and then went up to 20, or started at 20 went up to 30. Just changes by 10. So it doesn't have to start on the ground. T equals 1, the balloon is gaining altitude. So if I look here, I have a positive position, but do I have to be going up at 1?
No.
No. So technically I could go down and then go up 11.
Yeah, you could be losing
Right.
altitude, technically.
So I could go down, I just have to have a gain of 10. So I could go down 1 and then up 11. At time t equals 2, the balloon is 10 meters off the ground.
Yes.
Yeah.
But do I know it has to be 10? This is kind of with part A. Do I know it has to start on the ground? No. It's just 10 meters more than at... So it could have started at 10 off the ground and then went 10 meters above it. So it doesn't have to be 10 off the ground. It's just 10 more than what it started at. At time t equals 3, the balloon is losing altitude. Again, same idea with part B. My position is -7, so I could technically have went up, whatever. I could at 3, I could have went up and then down, up 3 and down, whatever. I can't do math. 10. So I don't have to be losing altitude. So if I look at E, at time equals t equals 4, the balloon is 3 meters higher off the ground than it was at time equals 0. Yes, because this is 10 and this is -7, so it's 3. It went 3 meters higher.
Didn't it go 17 meters higher?
So you're at. So your position is. Let's see.
His position is 10 and the position is 7.
How did he explain that to me?
So wouldn't it technically have been...
So your position is at. Your position's at 10 here.
Is it because the -7 doesn't represent a negative? Because it can't be negative feet off the ground, right? -7 is just like...
It's a position, so it's going to be.
So it's like the absolute value of the position.
Yeah, let me ask Goder again. He had already explained it, and I was like, oh, that makes sense, and now I can't remember what.
Welcome to my time.
Yes. These are always tricky to me when the wording one. Like I can do give me step by step. It's the wording one. So it's E. I'll check again and have a better explanation for you tomorrow. But okay. Yes, give me a second. Let me get this one done. Okay, let's look at 16. Another area one.
Would never repeat. I feel that I never repeat.
Okay. Find the area enclosed. Area enclosed by the curves x times 2 minus x and x minus 2x squared. First thought, if I'm looking for area between curves.
Set them equal to each other.
Yeah, and we're going to do integration. That's what the definition of integration is. But before I set up my integral, let's kind of get an idea of which one's above, which one's below. To do that, it's easy to know. It's easier to get your graph if you know where they intersect. So let's set them equal to each other. So that will be 2x minus x squared equals 8 minus 2x squared. Let's go ahead and add 2x squared over, subtract the 8, try to factor it. So this will become 1x squared plus 2x minus 8 equals 0. Like I said, usually you're going to have pretty straightforward ones because you cannot use calculator. This factors 2
X plus 4.
and x minus 2. So they intersect at -4 and +2. Again, I think it's nice to get actual points. You don't have to, but it's helpful when you graph it. How do I find actual points?
Plug it into the original.
Yeah, it doesn't matter which one. So if I plug -4 times 6, right?
-4 what?
So this becomes 2 minus -4, so 6 times -4, -24.
10.
If I plug in 2, I get 0. So they're going to intersect at -4, -24, and 2, 0. Kind of weird, but graphs don't have to be perfect. I just need to know which one's on top and bottom. We are in terms of x, so we are going to do top minus bottom. To graph this, I know I'm between -4 and 2. So 1, 2, 3, 4, 1, 2. I know what they intersect up here somewhere. Oh, negative. Just kidding. Down here somewhere. I don't have to be exact. And they intersect at negative or positive 2, 0. If I get this one graphed, this is going to be a parabola. If I do that, it's a parabola opening which direction? Down. And you can always just plug in points if you want to, or you could be cool and find the vertex and all that stuff. I know my zeros are 0 and 2, so I know it also is going to intersect at 0. Because if I said equal to 0, I have zeros at 0 and 2. I'm just going to kind of plug in points, honestly. So 1 is, when x is 1, it's 1, yes. When x is -1, it's negative -1, -2, -3. So we kind of have that shape, something like that. It's not perfect, but something like that. The other one is also facing down, a minus 2x squared. Maybe, what do you know your y-intercept is? You can find that easy enough. A minus 2x squared, y-intercept? Or from graphing?
So you got a 2.
It's 8. It's always your C value.
No.
So 1, 2, 3, 4, 5, 6, 7, 8. So just by that, I'm thinking it's probably that 8 minus 2x squared will probably be above the other one. But and I know it has to. So I'm just going to go ahead. I know it has to intersect there. So it looks something like this. Again, not a perfect graph, but I just got it so I knew which one was above and below. This would not be a V, this would be a curve, but whatever, it doesn't really matter. So as I set up my integral, it's in terms of x, so it's top minus bottom. And what x values am I between? -4 and 2. Top function is 8 minus 2x squared minus x times 2 minus x dx. So I've seen it before. Hopefully if 1 appears, you're able to at least put forth an effort. Going to be able to turn it into a polynomial. So -4 to 2, 8 minus x squared minus 2x, right? I didn't do anything stupid, did I? No, because it's minus this. So I just put a negative with the x and then distributed it.
Wait, what? I thought.
Because there's an x in front. It's not just a binomial. There's the x in front.
Is that how you do this?
Yes.
I don't remember.
You should. You did. I mean.
I thought you just broke it down into two. Did you break it down into two intervals?
No, top minus bottom doesn't change on this picture. So no, you wouldn't want to do that.
Why do you do that?
You do it if it changes which one's above, below. Like we had somewhere like, okay, on the left this function was above, but on the right this function was above, so you split it up into two. Yeah. Did I make any simplification error? I don't think so. Okay. So let's integrate this. 8x, integral of negative x squared. Negative 1/3 x cubed. Integral of negative 2x. Negative x squared. Evaluate it from -4 to 2. So plug in 2. Plug in -4. No space. So 16 minus 8/3. 2 cubed, yep. 8/3 minus 4 minus -32, -4 cubed, 64, -64. So plus 64 over 3 minus 16. This looks fun. Let's see. So we're gonna have thirds. So 48 thirds minus 8 thirds minus 12 thirds minus -96 thirds plus 64 thirds minus 48 thirds. I just get all common denominator of 3. So 48 minus 8, 40 minus 12, 28 thirds minus -96 plus 64 would be 28, -28, right? No, -32. -32 minus 48, -80, right? Making a stupid mistake, I don't think so anyway. Plus plus, that's 108 over 3, which is 36. Where? Who? When? Why? How are you doing?
How did you get 1/3? I got -1/3, yeah, and then the oh.
You good?
Yeah, 2 cubed
Okay.
is not 27. 3 cubed is 8.
Question, let's do one more and then I'll go over questions if you have it on homework. Questions? Okay, let's look at 17 is a fun one. Slope of the tangent line problems. We've seen them before. Yes. Let me get this done and then let me finish this and then before I start homework. Okay, equation of the tangent line. Equation of the tangent line, key thing to remember is the slope of the tangent line is the derivative evaluated at whatever point they give you. I need to take the derivative of this. First thoughts. Don't.
Add the 3 pi over 2?
No.
No?
Implicit, yes. This is implicit because
You have an x and a y on both sides on the same, like
it's not solved for y. So you do implicit when it's not y equals and it's hard to get y equals. This would be hard to get y equals because you have y as a angle with sine and you have y in front of either the x. So yeah, we're going to do implicit. So let's start doing this implicit. So implicit, remember, we take the derivative like normal. We put y prime wherever we took the derivative with respect to y. And then we solve for y prime and plug in. Derivative of pi sine y. Pi is just a number. So derivative of pi sine y is cosine y prime. So even though they throw a pi in there, don't try to do the product rule. Pi is just a number. Now the second, y e to the x, I'm going to have to do the product rule. So plus first y, derivative of the second, e to the x. I don't put an x prime, I only put a y prime when I take the derivative with respect to y. Plus the second, e to the x, times the derivative of the first, which is 1 y prime. So y prime. Equals derivative of negative 3 pi over 2, 0. Don't forget, derivative of that side. I need to solve this for y prime. Thoughts? Don't let the brackets be confusing to you.
You just take a y prime out.
Well, I'm going to move this over first.
Yeah.
So we're going to subtract the only thing without y prime to the left, to the right side. And then we're going to take out a y prime. And then, to find y prime, we've done this before. Y prime, divide. So y prime equals negative y e to the x over pi cosine y plus e to the x. But we're not done because I want the slope of the tangent line. So I need to use this equation, plug in x and y to find a slope, and then I can plug in slope m and x, or y equals mx plus b, plug in slope x and y and find b. So let's start plugging in. Y is negative pi over 2, so it's going to become a positive pi over 2, e to the 0 over pi cosine of negative pi over 2 plus e to the 0. Anything to the 0 power is 1, so those will kind of work out nicely. So I'm going to have pi over 2 over, what's cosine negative pi over 2?
Negative.
0. It's negative pi over 2, you're going to go down, it's 0. So it should just be 0 plus e to the 0, which is 1, so just pi over 2. Again, it's kind of weird to see slope as with pi, but it's just a number. So it's my slope of my tangent line. So to find the equation, I take y equals pi over 2x plus b, like you did from algebra. Y is negative pi over 2. X is 0. So b is negative pi over 2. So your equation is y equals pi over 2x minus pi over 2. Okay. Okay, so that's a good start for that. Tomorrow we'll finish this. I may have time to throw in. How far am I away? Not too far. Yeah, that's fine. Okay. Derivative homework packet. You got Friday. The key should be on Classroom, correct?
Yeah.
That's what I thought. I put it on Friday.